Okay, so previously we talked about graphing linear equations. This is a very similar topic. Only major difference here is that instead of dealing with an equation, we're dealing with what's called an inequality. And inequality means it has a greater than, a less than, or greater than, equal to, less than, equal to sign. So it's really the same procedure as before. There's just two extra things, and these things might not make sense to you until we actually do them. But when you're graphing a regular line, it's a solid line. But if you have an inequality on occasion, and I'll show you how to tell when it is and when it isn't, on occasion you'll have to draw, instead of a solid line, a dashed line like you see right there. Okay, and then the other thing is to decide whether to shade above or below the line. Obviously, if you're graphing y is greater than 3x, that would mean shading above that line. And if you're graphing y is less than 3x, that would mean shading below. Okay, so that might not be entirely clear until we do a couple examples, so that's what we'll try to do right now. All right, so same procedure as before. The first thing that we generally always want to do is it's usually easiest to graph them when they're in slope-intercept form, so we're going to change the top one. We get y is greater than or equal to negative x plus 3. So let's graph this. Now, notice that this right here is a greater than or equal to sign. So because it's equal to, that means y is included in this line. It could actually equal that line, and that's how we know it's going to be a solid line. The way that you show that y is only greater than or only less than would be to use a dashed line, and that's going to be this second line that we have to graph. So we graph it the same way. Negative x plus 3, there's the y-intercept at 3 right there. And the slope, if you were to write negative, that's a negative 1. If you were to write negative 1 as a fraction, it would be negative 1 over 1. So negative 1 means go down 1 over 1, go down 1 over 1. We'll do that a couple of times here. And then we could also go up 1 to the left 1. Okay, again, this is going to be a solid line because y is not only greater than that green line, it also could be equal to that green line, greater than or equal to, and therefore it's a solid line. Okay, the second line right here, it will subtract 3x from both sides, and let me just come over here so we have more space. So we have negative y is greater than negative 3x plus 1. Now this part is important. When we solve for y, remember slope-intercept form is y equals mx plus b. We're obviously doing the same thing just with the greater than, but it's y, it's not negative y. So we have to divide by negative 1. This is important. You might remember this from another section. When you multiply or divide by a negative number, which in this case we just divided by negative 1, this sign has to flip directions. So previously it was opening towards the y, now it's going to change because we divided by a negative. Negative 3 over negative 1 is just positive 3, and 1 divided by negative 1 is negative 1. So here's our second line. This tells us that we should use a dashed or a dotted line. Y is less than, but y doesn't actually equal this red line. So it's less than, the dash shows that it never actually reaches that line, it never equals it. This has a y-intercept right here of negative 1, so I'll put that there. And this slope is the same as 3 over 1, which means go up 1, 2, 3, go over 1, and right away we can see where they meet. Okay, so far that's very similar to the procedure we've used before. Here's the second new part. The first new part was deciding if it's solid or dotted. The second new part is deciding where to shade. Because notice we have to shade in a region that satisfies this condition up here, where y is greater than that stuff, but y is also less than that. Okay, so one thing I hope will make sense as I describe this, notice that we kind of get like almost an X shape right here. If you look at the red and the green, it kind of forms an X shape, and X has 4 regions, right? Region 1, 2, 3, and 4. So let's label these. We'll call this region A, we'll call this region B, we'll call that region C, and we'll call this region D. Okay, let's focus on one line at a time. So let's start with the green line right here. This green line says y is greater than the green line. So if you look at regions A, B, C, and D, there are actually 2 regions where y is greater than the green line. And those are these 2 regions right here. Okay, you might have to kind of pan back or take I guess you'd say a bird's eye view of this line. If you kind of look at this here, this green line right here, I'm going to have to outline it in purple so it's not green, but this line that I'm kind of tracing right here, okay, below the line, if you were underneath that line, you'd be in regions D and C. But this tells us right here that we're supposed to be above that line. We're greater than. That puts us in region A and B. So we know for sure that wherever we need to shade, it's going to have to be in regions A or B, because regions A and B is where y meets this condition. Y is greater than that line. Okay, the problem is we can't shade in both of them. So let's decide should it be region A or region B? How do we decide? We decide based on this other line. This other line, the red line, it says y is less than the red line. So now focus on the red line right here. The red line obviously is this right here. Focus on that red line. Out of region A and B, which region, region A or region B, is below or less than the red line? Because that's what this says right here. This says y has to be less than. And you can probably tell region A right here, this is above that red line. Okay, region B is underneath it. So the place that we should shade is we should shade that only in region B. Okay, that's how you would graph an inequality. Okay, the next case is, so that obviously that would be a case where they do meet in one point. This next line that I'm going to show you, number 2, is what's called a special case. This is like that other example we did where the lines are parallel, they never meet. Okay, so let's verify that these are going to be parallel lines. We'll subtract x from both sides, and we'll get y is less than negative x minus 3. This should be, try to think to yourself, should that be solid or dashed? And hopefully you can say that it's going to be dashed because y is only less than, it's not greater than, or sorry, it's not less than or equal to. That has a y-intercept of negative 3, and then that is the same as negative 1 over 1. So that means go down 1 over 1. We'll do that a couple times, and we'll also go up 1, left 1, just to balance things out. Okay, again, I'm going to make this a dotted line right here, and that's going to give us our first line. Second line, let's also put that in slope-intercept form. Come over here. We'll get y is less than or equal to negative x minus 2. Think to yourself for a second. Ask yourself, should that be solid or dotted? And in fact, it should be solid because y is less than or equal to. Ask yourself, what's the y-intercept here? The y-intercept is negative 2. So I'm going to put a dot at negative 2, and then this slope is negative 1 over 1. So down 1 over 1, down 1 over 1, down 1 over 1, and let's go up the same distance. Okay, this should be a solid line. Okay, so notice I apologize for my line not being very straight there, but if it were a perfect line, or much better than I had drawn it, notice that the slope right here, that number is negative 1, and the slope right here, that number is also negative 1. So what kind of lines are those? Those are, of course, parallel lines. That means they never meet. So now the question is, how do we shade this? So we get, in this case, we don't get 4 regions, we don't get an X, we get kind of 3 regions here. So I'll call that region A. Region B is like in the middle, sandwiched in between those. And region C is right there. Question is, where do we shade? So we need to shade in a place that satisfies both of these, if possible. Sometimes it won't be. Okay, so this right here, this says y is less than the purple line. In which region, A, B, or C, is y less than the purple line? And the answer is region A. Okay, region A is the only thing less than the purple. So I'm just going to shade this a little bit, but not too much, because I also have to deal with this line right here. Make sure we satisfy that. So this one right here says y is less than or equal to the red line. Now here's the thing. Notice that both region A and region B are both less than the red line. But we have to satisfy both of these conditions, both of these criteria. We have to shade in a place that's going to make the purple line true and the red inequality true. Both A and B work for this line. Both A and B are less than, but only region A works for the purple. If you were to shade region B, that would not be less than this purple line. So that means the only place we're going to shade is region B. Okay, I don't have an example up right here, but I just want to show you the third possible case, or mention it. The third case would be, suppose you had something where region A was satisfying the purple and only region C was satisfying the red. So a case where that could happen was if that sign were reversed, if that had said y is greater than, then you'd have region A and C, and you can't shade in both. So in those cases, what you would do is you would essentially leave it unshaded. It's impossible that you could be both less than the purple and greater than the red at the same time. Okay, so that's how to graph linear inequalities. Remember, the two differences from equations is whether you have a solid or a dotted line, and that you can tell by looking at this, whether it's just less than or less than equal to, and then where do you shade. And I would recommend carving it up into regions like we did, region, in this case A, B, and C, or in this X shape, you're going to have 4 regions, and then just treat one line at a time and see where you should end up shading, and usually there's only one region where you can shade and still satisfy the conditions.